4 days ago, a team of astronomers released a finding that has quietly sent shockwaves through the planetary science community. They were not looking for what they found. They were analyzing orbital data from distant objects at the very edge of our solar system. Objects so far from the sun that light takes hundreds of years to reach them. Objects so cold that their surfaces sit just a few degrees above absolute zero. Objects that have been drifting in the outer darkness for billions of years, largely undisturbed, largely unexamined, largely unknown. And what they found in that data has just made one of the biggest unsolved mysteries in all of astronomy significantly more complicated. Something is out there. Something massive. Something hidden. Something that has been pulling on the outer edges of our solar system for so long that the evidence of its gravity is written into the orbits of dozens of objects billions of miles from Earth. And the finding released 4 days ago did not bring us closer to finding it. It made the search harder. It moved the target. It suggested that whatever is hiding at the edge of our solar system is not where anyone thought it was. This is the story of Planet 9, and the reason it matters right now more than it ever has before is that for the first time in the history of this search, we have a telescope that might actually be able to find it. The Vera C. Rubin Observatory, sitting high in the Atacama Desert in Chile, is coming online this year. And when it does, it will scan the southern sky with a level of detail that has never been achieved before in the history of astronomy. If Planet 9 is real, Rubin should find it, and if Rubin does not find it, the implications are almost equally significant, because something is affecting the outer solar system. The orbits are wrong. The math does not work without something massive out there pushing and pulling. And if it is not Planet 9, the question of what it actually is becomes even more disturbing. Let me take you back to 2016, because that is where this story properly begins. In January of 2016, two astronomers at the California Institute of Technology published a paper that changed the conversation about our solar system. Their names are Konstantin Batygin and Michael Brown. Brown is the same astronomer who discovered Eris, the large dwarf planet whose discovery directly led to Pluto being reclassified and removed from the list of official planets in 2006. He is, in certain corners of the astronomy community, known as the man who killed Pluto. In their 2016 paper, Batygin and Brown laid out a specific observation and a specific conclusion. The observation was this: 6 distant objects in the outer solar system, small bodies orbiting far beyond Neptune in a region called the Kuiper Belt, were all doing something that the known laws of physics said they should not be doing. Their orbits were clustered, grouped together in a way that pointed in the same direction of space. The probability of this happening by chance, purely through random orbital evolution over billions of years, was calculated at roughly 1 in 10,000, 1 in 10,000. The conclusion Batygin and Brown drew was straightforward. Something is causing this. Something with enough gravitational mass to reach billions of miles across the outer solar system and shepherd these distant objects into their unusual orbits. Something that has been doing this for a very long time. Their calculation of what that something would need to be produced a specific answer: a planet. Approximately 5 to 10 times the mass of Earth, orbiting the sun at a distance roughly 20 times farther out than Neptune. Taking somewhere between 10,000 and 20,000 years to complete a single orbit, so distant and so cold and so dark that every telescope ever built had simply never detected it. They called it Planet 9. The scientific community's reaction was divided. Some researchers found the evidence compelling and immediately began working to either confirm or refute the hypothesis. Others were skeptical, arguing that the orbital clustering could be explained by selection bias in the data, meaning that the strange pattern in the orbits might be an artifact of where and how astronomers had been looking rather than evidence of a real gravitational influence. That debate has been running for 10 years now, and it has not been resolved. What has happened in those 10 years is that the evidence has gotten both stronger and more complicated. More distant objects have been discovered. More unusual orbits have been cataloged. More mathematical models have been built trying to explain what is happening at the edge of the solar system, and the picture that has emerged is this. Something out there is definitely doing something to the outer solar system, but what that something is and exactly where it is has gotten significantly harder to pin down. 4 days ago, the mystery got harder again. A new analysis of the orbital data for distant Kuiper Belt objects was published. the researchers found something that directly challenges the original Planet 9 prediction. The objects they studied are not behaving quite the way the Planet 9 models said they should be behaving. Their orbits are more stable than the models predicted. Their clustering, while still real and still statistically significant, is slightly different from what you would expect if a planet exactly the size and distance that Badigan and Brown proposed was responsible. What this means, according to the researchers, is one of two things. Either Planet 9 does not exist and some other explanation is responsible for the orbital clustering, or Planet 9 exists, but is significantly farther away than anyone thought. So far away that its gravitational influence is more subtle, more spread out, more difficult to detect in the orbital data than the original models predicted, and here is why that second possibility is the one keeping planetary scientists awake right now. If Planet 9 is farther away than the original estimate, it is also colder, darker, dimmer, harder to find with any telescope. The original search parameters, the specific regions of sky that astronomers have been scanning with powerful telescopes for the past decade, looking for a faint moving object, may all be wrong. The planet could be sitting in a completely different part of the sky, further from the sun, further from any telescope survey that has been conducted so far. It could be right there, in the data that nobody has analyzed yet, in the region of sky that no systematic survey has reached, in the darkness beyond the edge of everything we have mapped. The Vera C. Rubin Observatory changes this calculation, and it changes it completely. Rubin is not a normal telescope. It is something that has never existed before in the history of astronomy. Its mirror is 8.4 meters across. Its camera has 3.2 gigapixels, which is the highest resolution astronomical camera ever built. It will photograph the entire visible southern sky every 3 nights, creating a time-lapse record of the outer solar system of unprecedented completeness. The way you find a distant planet is not by taking a single image and spotting it. Planets at the distance of Planet 9 would be so faint that they would be essentially invisible in a single photograph. What you do is take multiple images of the same region of sky over weeks and months and look for an object that moves. Stars do not move relative to each other on human timescales. A planet, even a very distant one, will shift its position slightly from one image to the next. Rubin is designed specifically to detect this kind of motion. Its software will automatically compare images taken days or weeks apart and flag objects that have moved. If Planet 9 is within the region of sky that Rubin will survey, and if it is within the distance range that the current orbital analysis suggests it should be, Rubin should find it within the first year or two of operation. Konstantin Badigan, the Caltech astronomer who co-authored the original Planet 9 paper, recently said something that captures exactly where the scientific community stands right now. He said that if Planet 9 is real, Rubin has a good chance of finding it. But he also said something else that is worth paying close attention to. He said that even if Rubin finds something, it might not be Planet 9 as originally described. It might be something different, something unexpected, something that fits the orbital data but that nobody predicted. He called it Planet 8.5 as a joke. But the joke contains a serious point. Whatever is affecting the outer solar system, whatever is writing its gravitational signature into the orbits of distant objects billions of miles from Earth, it may not be what anyone imagined when the search began. Let us talk about what Planet 9 would actually be if it exists, because the answer is stranger and more interesting than most people realize. The planets in our solar system fall into 2 broad categories. The inner planets, Mercury, Venus, Earth, and Mars, are small and rocky. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are enormous and gaseous. There is a curious gap in this family portrait. Our solar system contains no planets between about twice the mass of Earth and about 15 times the mass of Earth. But when astronomers look at other solar systems around other stars, they find that this size range, sometimes called super-Earths or mini-Neptunes, is actually the most common type of planet in the galaxy. Planet 9, at 5 to 10 times the mass of Earth, would fall squarely in this missing category. It would be the kind of planet that is extremely common everywhere in the galaxy except, apparently, in our own backyard. Except it might be in our own backyard, just hiding. Why would a planet of that size be hiding so far from the sun, so far from everything else in the solar system? This is where the story reaches back to the very beginning of our solar system, 4.5 billion years ago. The leading theory for how Planet 9 ended up where it is involves the early chaotic period of solar system formation. In the first few 100 million years after the Sun formed, the giant planets were not where they are today. Jupiter and Saturn and Uranus and Neptune were all in different positions, closer to the Sun, in slightly different orbital configurations. And as they migrated outward to their current orbits, their enormous gravitational influence threw enormous amounts of material around the inner solar system. This period, called the Late Heavy Bombardment, is responsible for the craters you can see on the Moon. It is the period when Earth was struck by a Mars-sized body whose material eventually became our Moon. It was violent and chaotic, and it ejected enormous amounts of material out of the inner solar system. One of the things it could have ejected was a planet that formed in the inner part of the solar system, that grew to 5 or 10 times the mass of Earth, and that was then flung outward by a close gravitational encounter with Jupiter or Saturn, flung so far outward that it ended up in a distant elliptical orbit far beyond Neptune, where it has been drifting in the dark for 4.5 billion years. This is not speculation. Computer simulations of the early solar system consistently show that one or more planetary embryos could have been ejected from the inner solar system during this chaotic period. Most of the ejected material would have been sent flying out of the solar system entirely, lost to interstellar space forever, but a small fraction could have ended up in bound orbits, trapped by the Sun's gravity at enormous distances, trapped where nobody would think to look, where nobody has looked effectively until now. There is a second possibility that the planetary science community does not discuss as loudly, but that the data allows. The possibility that Planet 9 is not a planet that formed in our solar system at all. Early in the solar system's history, when the Sun was young, it was part of a stellar cluster, a group of stars that formed together from the same giant molecular cloud of gas and dust. Stars and clusters are close to each other, cosmically speaking, close enough that they can gravitationally interact, close enough that one star can steal material from another. Computer simulations have shown that a planet orbiting a neighboring star in the early solar system could, under the right conditions, be transferred from that star's gravitational influence to the Sun's, captured, incorporated, adopted into our solar system from another star system entirely. If Planet 9 is a captured planet from another star, it would have formed under completely different conditions than our own solar system. It would have a different chemical composition, different internal structure, different history. It would be, in a very real sense, an alien world. Not alien in the science fiction sense, but alien in the literal sense of belonging to another star, another system, another place in the galaxy. And it would be sitting out there right now, in the darkness beyond Neptune, orbiting our Sun as though it had always been there, waiting to be found. The Vera C. Rubin Observatory will take its first survey images this year. The data will begin flowing. The automated detection software will begin flagging moving objects. And somewhere in that flood of data, the answer to one of the oldest remaining questions about our own solar system is either waiting to be found or waiting to tell us that we need to ask a completely different question, because here's the thing that the most recent finding, the one released 4 days ago, has made clear. The outer solar system is not behaving the way our models say it should. Something is wrong with our understanding of what is out there. Either there is a planet we have not found yet, or the dynamics of the outer solar system are being driven by something we have not correctly accounted for, the self-gravity of the Kuiper Belt itself, the influence of passing stars over billions of years, some other large body we have not identified. Something is wrong, and we are about to find out what. Badajan recently said that in the next few years, either Planet 9 will be confirmed, or astronomers will have to conclude that the outer solar system is far stranger than anyone imagined. That the orbital clustering they have been studying for a decade has some other explanation entirely. An explanation that does not yet exist in any textbook. Either the solar system has a hidden planet, or the solar system is doing something that our entire model of how solar systems work cannot explain. Neither answer is comfortable. Both answers are extraordinary, and the telescope that will force one of those answers is running right now, in the Atacama Desert, under the darkest skies in the southern hemisphere, scanning the edge of everything we know about our own cosmic neighborhood. The next few years of data from Rubin will be among the most consequential in the history of planetary science, not because anyone is certain what will be found, but because the uncertainty itself is about to end. Something is out there, or something is wrong with our understanding of everything out there. We are about to find out which. Sky Pulse is going to be tracking every data release, every preprint, every conference announcement that comes out of the Planet 9 search over the coming months. Because when this story breaks, and it is going to break, it is going to be one of the most significant announcements in the history of space exploration, and we are going to be here when it does. Subscribe to Sky Pulse, turn on every notification. The edge of our solar system is about to give up one of its oldest secrets. This is Sky Pulse. Stay alert. We will see you in the next one.